Hello everyone, we are excited to introduce our paper, Unsupervised Discovery of Long-Term Spatiotemporal Periodic Workflows in Human Activities. Long-term periodic spatiotemporal workflows are common in everyday life and work. For example, in a production line of a factory, workers follow a long-term workflow to perform periodic assembly activities. People may follow a long-term route to repeatedly do hiking exercises. If we can automatically extract the periodic workflow from observed activity data, it can help to quantitatively analyze our working and exercise procedure, to optimize the working environment and our health training. However, up to now, we lack a benchmark to study it. The existing related benchmarks either focus on short-term periodic activity detection, such as to count simple repeated jumps, or long-term non-periodic activity segmentation, which suppose only a single period is given. Therefore, we want to bridge their gap to make a long-term periodic workflow benchmark. In our work, we propose the first long-term periodic workflow analysis benchmark, which covers 580 human activity sequences featuring diverse real-world scenarios, such as factory production, exercise training, and shuttle routes. Our dataset covers rich modalities, including 3D body and hand pose sequences, 3D indoor trajectories, and 2D outdoor trajectories. We propose the first long-term periodic workflow analysis baseline, starting with spatiotemporal clustering to create a set of activity tokens, each represented by its cluster centroid. Next, we tokenize all frames of an activity into a symbolic transcript using both hard and soft tokens. The hard token for each frame is determined by the symbol of its nearest cluster centroid, while the soft token consists of a vector of normalized distances to all cluster centroids. We then form a 2D matrix from the soft tokens of all frames and analyze it in the frequency domain. We identify a rough periodic scale along the temporal axis through re-ranking the dominant window candidates and apply it to segment the entire transcript. Finally, we propose an innovative sequential mining algorithm called MTA to distill the common pattern within all segmented hard tokenized transcripts. This approach yields unified periodic activity workflows with precisely defined boundaries. Please see our demos for long-term periodic workflow detection in human activities.